see. Okay. Yeah, topic is recommender system. Already I talked in the last session. Okay, here I will be seeing actually how the Amazon and others, they are not exactly, because as you know the industry will not reveal exactly how the recommendation process or anything exactly, but it is very close to the exact that how they provide the recommendation. Okay. So I start my talk with this, with this slide. Okay. So what do you see on this slide? So there are many headset, right? Headphone. So now I wish to choose any one of them. Okay. So we have the huge information, but which information will be suitable for me? In the same scenario here, there are plenty of headset as you can see, but which one should I choose? So in this situation is something called information overload. We have the plenty of information, but we are little bit confused actually which information will be very suitable for me. So in more formally, that is information overload is a scenario where the consumers are unable to make decision on a product due to too much of available information. Okay. So in this scenario actually recommender system or recommendation will be very helpful. And nowadays recommender system have been used in many domains, starting from health recommender system. Food and other thing is already there for the last 20 years. But now also people suggesting for health related recommender system. Course recommendation and some. Okay. So there are many applications. Here you can see movie series on the OTT platform and YouTube, and everywhere you can see, start watching anything and you will get the corresponding recommendation from YouTube. Okay. And then Netflix, Amazon, YouTube, Spotify and so on, many more. Okay. Even crops for cultivation and so on. Okay. So this is the recommender system actually started maybe in the last decade of the last century, in 90s and so on, and still it is evolving. And after introduction of deep learning in 2014, so then many more algorithms are coming up. There are story here. So initially the recommender system communities they thought that deep learning is not their cup of tea, so therefore they should not apply it. And therefore whatever the work, while the image processing guy and others, they started so early applying the neural network and deep neural network, but in recommender community, that scientific recommender system, they started little late. From 2016, 2019 or 2017 we see a good paper on the recommender system, which is very simple neural network model, and then later on it, like anything now people everything talking about the neural model. Okay. So here this diagram basically talks about the type of recommender system based on the type of the data is being used by a system. So based on the type, so there could be a type is like as you can see on the content based recommender system, and then collaborative filtering, and then the mixing of this. Content based means initially actually one has to register with the system. I have to say my age and then where from I am and what I am doing and so on. So it was like a registration process, and then similarly item also will be described. What is the item, what is the size, what is the color, and all other information. Basically both side is the content, and wherever the content is matching, maybe I like some movie from the particular actor or actress, and then maybe if there is some movie where the corresponding actor or actress is performing, so in that case that they will match and so on. But very often what we see, I like this object, but maybe it is very difficult to figure out why do I like. Let's say in a short movie, So I like this movie, but it is very really difficult to tell actually why do I like. So therefore many cases it is very difficult to figure out the corresponding features. Okay, maybe the latent feature is a good idea, but yeah, that we'll see. Okay, and there are many stories. So when I teach also along with that, I also say the story associated with the particular method if there is any interesting story behind it. So therefore it's like only based on the content information. And other thing is the collaborative filtering. Collaborative filtering, as I said, so after purchasing some product, Amazon asks you, can you give the rating on this product or any kind of service? Okay. So they are actually product, what product is, or which product is not actually important. Important is what rating you are giving. Okay. So it may be the rating pattern is the same for an item which is basically the domestic or utensil used, and then other product maybe the electronics some item. So there is no similarity if you see the feature wise, but the rating pattern could be the same, and then the two products could be the same. Okay, so that is the only the table is this table. So here we don't use explicitly any information, neither from the users, whether user age, user what user is doing, but which region, whether he is from Varanasi or he is from London, we don't use here. So only we use that users, and then my preferences. If I am a user, so they will use the my preferences. Preferences means what rating I gave earlier on different items. Okay. So we'll have essentially we have the rating data set as you can see here, and then rating data set based on the rating information we can find that one class of collaborative, one class of recommender system, that is something called the collaborative filtering. And in academic arena, actually this method is very popular. And then it was reported in 2005 and so on that Netflix they use the actually collaborative filtering. So nowadays it's difficult to know which technique they use. Obviously it is mixture of content and collaborative filtering, because it's not only that rating you are giving, sometimes you give the reviews also. From the reviews one can analyze the sentiment, whether it is a positive sentiment, whether it is a negative sentiment and so on, and then whether it is a sarcastic statement and so on. So based on that you can figure out some kind of rating, and then you can mix with the say hardcore rating and so on. So nowadays even the people nowadays also they see the image of the particular product. Okay. So you collect the information from multiple scenarios and then mix them, and then you find end of the day you find some kind of what is called is representation of the objects, and then you provide the rating and so on. Then we'll go with slowly, so it will be easier for everyone to understand than being on the top. Okay. So this is like one typical diagram. As you can see, the recommender system in the middle. So it needs the data set. As I said, data set could be the rating, the table only, or it could be the information about the user and item. And then this guy is asking for recommendation. And here the item is like the movie. So then it gets the recommendation. This guy gets the recommendation of the movie. So maybe this type of picture I will be showing many times here. Okay. So now, as I said, the source of information. I already said the source of information will be content based, as you can see, and then source of information could be feedback, as I said, explicit rating. Okay. And then maybe say implicit rating. Implicit rating means you are watching the particular image and you are hovering on the image, but maybe you are not interested to purchase. Obviously you were interested, and for due to some reason you did not purchase. Okay. So that information is also getting captured. So you may in future you were interested for somehow, and then accordingly, so that will be also your history. So that will be used in future recommendation. Okay. So that is all about the explicit information, implicit information, and then that can be in a formatted like user ID, item ID, rating, user ID, item ID a number of times. Number of times means, let's say it's here the item is not only the that movie or on item, that could be any music or movie you are watching how many times, right? So that also give you the number of times you are consuming that particular item. Maybe news, same news you are studying, you are reading for 1 to 2 times, or maybe there's some kind of music or song you are listening for more than 1 time. So that means you are listening means you are liking that particular song. So that information also we can figure out. So that is the number of item, number of user, and so on. Okay. So here the content-based information for the movie, it could be genre, it could be directed by running time and the plot and so on. From there we can find the information about the item. So we can write in a what is called is like in a format, that is item ID, genre, and director, and so on. So similarly, demographic information. So sitting in Kolkata or here may not have the same preferences the guy sitting in the London or maybe in the season. Okay. So those information also we can capture. And many times actually we are influenced by the friends, right? So therefore, it is very important to know that who is your friend. Okay. So therefore, that information is also there. That is source of social information. Okay. If somehow we get it. Okay, so this is all about the all information data set, and then finally we type of recommender system according to the input. In case of the collaborative filtering, we use the information that is item ID, genre, and this one, and rating, and so on. So maybe I can skip. In collaborative filtering, we will have this information: user ID, item ID, and the rating. Or consumption, user ID, item ID, and number of times. Here we are not using any kind of person specific information. Okay, so this is one example. Let's see. So we have the user ID, and then on the right side we have on the column wise we have the item ID, and then user U1 has rated the item with I1 with 5, I2 with 5, and so on. And so user U3 on the item I10 we don't know. The user U2 has not rated the item 10. And then task of the recommender system is to whether the item 10 will be recommended or not. So ideally this can be solved in many ways. One of them is we first predict at that particular position what could be the rating, okay, and then if predicted rating is above, say some threshold, let's say 4 and above, then we can say okay, this item also could be recommended to the user. We will see. Okay. So here is like we can binarize, instead of having 4, 3, 2, we can say +1 and then 0 and so on. Okay. So this is also same thing, conjunction, yeah. Or here collaborative filtering at the end, we get this information. Okay, for content based we have this type of information. So this is one example. Let's say we have the news recommender system. The news is like the World Bank projects, global gross domestic product growth to hit 2.4% in 2016 and so on. So we have the item here is news. Okay. So then ideally simplest way, but nowadays people don't use, because as you know that now people talk about embedding. Okay. So this was maybe in the last century, last decade of the last century, the people used to develop the recommender system for content based. Nowadays, as you know, the transfer model and other thing, so it is totally shifted like anyway. But we'll know from here. So let's say this is another news. What we do it? We combine the all news or all news part. We pick the important word. Important word. How do you know that one word is appearing many times? Okay. So and then what we do on the column side, and then row side is the corresponding item. Item means that is news article. So then how many times that is goal? Four times the word goal appeared in the news article I1 and so on. So and then what you do it? Now myself I consume some news article. That means I consume item I1, I2 and I3. So based on that the system will provide the recommendation. Okay. So that is the task, that providing news recommender system. Okay. So how do you proceed? So basically on the item side we will have the item term and the number of times it appears. and the consumption user ID and item ID. And this fellow has consumed the news, and then we have to provide the recommendation. So this is the task. Okay. So here we go. What do we do it here? So this is the table, we have the information, and then what do you do it? We'll create the virtual item out of the consumed item by a user. Okay, say user has consumed the item I1, I2, I3. So we combine these three items and then we'll create an item, that is virtual item, and this virtual item will be compared with the non-seen news. Okay, the news which he or she did not read. Okay, so those items will be those will be compared, and wherever there will be high similarity value, that corresponding news article will be recommended. Okay. So let's say user has consumed the item I2 and I10. So I2 has 5, 1, 5, then rest 0, that is. Now what we do it, we normalize. And so for item we will do the same thing. Then what we do it, we just add it and then normalize. So that will represent the user. And then what we do it, whatever these combined values, that will be compared with the other items which are not consumed. Let's say I will compare with the I11, I will compare with I8, I7 and so on. Wherever the similarity value is high, how do we compute similarity? So this is a document, right? So document to document computation, there is something called cosine similarity. Cosine similarity is nothing but, so angle, so if you do the dot product of the two vectors, so then what is the dot product of two vector A and B? So we'll get the AB cos theta. So that cos theta is nothing but the similarity value between the vector A and B. Okay. So then we'll get the virtual item here. We combine it, we'll get the virtual item here, and then finally this virtual item will be compared, this virtual item will be compared with all other items, and then finally we'll get a score, and then we recommend the item here. Okay. So first phase is completed. Next phase is like here. So I am more interested on the collaborative filtering. Okay. So because that collaborative filtering still people work, in content also they work, but in totally different way. Nowadays people use the content-based filtering. Okay. So on this slide, as you can see on the rating data set, we use the collaborative filtering. Okay. So here we go. So this is the slide actually you need to understand to understand the collaborative filtering. Collaborative filtering essentially is divided into two parts. One is something called neighborhood-based approach. Other is something called model-based approach. But first try to understand what is the neighborhood-based approach. So neighborhood-based approach is also divided into two parts. One is user-based, another is item-based. So essentially this figure, so on the left side, so this is, I repeat the same thing here. So I repeat the statement earlier I told. So I said is very often we are influenced by our friends. So user-based collaborative filtering is something like that. So I will be recommended an item which are preferred by my friends. So this is the logic for the user-based collaborative filtering. So I repeat it. I will be recommended an item which is preferred by my friend, but which are purchased or which are actually preferred in a sense, which are the good item for my friends. So now question, how do we compute who are my friends? We don't know each other because it is all about the Amazon database. Okay. So therefore, Amazon compute the similarity between myself and all other users, and then wherever similarity measure is high, so that user will be considered as my friend. So, and among the similarity measures, wherever we find the top K users we can choose, and those top K users will be my friends. Is it clear? So now you look into this diagram here. Okay, so let's say so dotted line are actually already consumed item. Okay, so therefore that girl, you say she has consumed grapes, she has consumed strawberry, and she has consumed watermelon, and she has consumed the orange. Okay, now I have to say whether this guy, what are the item could be recommended to this guy. Okay, this guy means this guy. Okay, so now how will you see? I will see who are my friends, and say we find this girl is my friend, and so therefore I will see whether those items, what are those other items are already consumed by this girl. So therefore this item and this item, so these two items could be recommended to myself. Okay, so therefore as I said that what item will be recommended to me, it depends on what are the items consumed by my friend, and they must have given the good rating. Okay, so this is something called item based collaborative filtering. Sorry, and on the right side is called this is user based, and on the right side is the item based collaborative filtering. What item based collaborative is saying is very likely that whatever the item I will purchase, okay, that will be the quite similar item that have already been purchased by me. That means whatever my history, what is my history, and maybe I will purchase the similar kind of item. Okay, so that is something called the item based. Okay, so there may be a debate. Why do I purchase? Just now I purchased laptop. Why do I again purchase some other, say let's say tab and so on? Okay, but this is all about the item based collaborative filtering. Okay, so now how it works I will be describing in detail. Okay, because as I said the collaborative filtering works on the rating data set, right? So this is all my rating data set. We have the user ID and then all the item ID on the column, and this is the rating. Let's say what is the task? Task, I think. Yeah. So task is to, you have to provide the recommendation. Task is to provide the recommendation for user info, and it is very much clear to you. So I don't need the recommendation for the item which are already consumed by me. I know the item test, right? So don't give me the lecture about that item because I already consume and I know my test. So it is all about the item which are not purchased. So tell me about that item, or you provide the recommendation for the non-rated item. Okay. So therefore, if you provide the recommendation for user U4, you have two choices, either I4 and I5. If you give recommendation the both the item, there is no meaning, right? So I said the all unrated item is your recommended list. It does not make any sense. So therefore, what you have to do it? You have to say either U4 will be recommended or I5 will be recommended. Because here we have a very small example. Okay? So now what I do it, I will predict the rating for I4 and I will predict the rating for I5. Now if I go for the user-based collaborative filtering, so first what I will see, find user who rated the target item. Here target item is I4, and for which user I am trying to find the recommendation, that user is called the active user. This is the terminology we use. For which user we are trying to provide the recommendation, that user is called the active user, and for which item we are going to say whether this item will be recommended or not, that item is called the target item. So now for the item I4, I will see who are the user who rated the target item. So in this example, except U4, all users have rated the target item, right? So now what we do it, that is the find the set of neighbor of the active user U4. So compute the similarity between the active user U4 and the all user rated the target item I4. That is, you compute the similarity between I4 with U1, I4 with U2, I4 with U3, I4 with U5. Okay? So you use some kind of similarity measure. Okay? And you find the how can you find the similarity between user to user? I will show you. Okay? So there is something called the Pearson correlation. Okay. So that is you can find the similarity between user to user using Pearson correlation. Okay. So I'll show you. So now what you do is compute similarity between active user U1 and all other users, and then what you do, you select the k user. If you have many users, then you select many times. What you do, say let's say you are in a problem, right? So you need to take some decision, whether you will go for movie. This is very simple decision, maybe some very important decision, okay, life-changing decision or something. It appears to you it is life-changing decision, but down the line, after some time, you feel, oh, it was not so important. Like when you miss the train at that moment, you feel that is the that you need to get it. But later on, you see, if you think of after a year, okay, it was not so important. Okay, so in that scenario, what do you do it when we are really confused? So we call to our closest friend, okay, and then we call to other friends. But so let's say that closest friend is saying you don't do it, okay, you don't agree, okay, and then all other friend is okay, you should go ahead. So in that case, what we do it, we give more importance to the closest friend, and then maybe if you have a second closest friend and say second, third, and so on. All right. So similarly here, when we provide the recommendation, who is my closest friend and what he is saying, here is what rating he has given. He has given the rating 4. Okay, so we will give importance to the 4, but we multiply it with his comment. Comment is nothing but the closeness. So that is the closeness will be multiplied with the rating. Okay, so therefore we will select all the k neighbors or not. I have a say 1000 Facebook friends. So do you take any concern when you take a decision? Okay, so those are is like we have a friend, but not all similarity value is all negative. Okay, so then only the positive value will take it, and then k neighbors, and then we will go ahead. So then we apply the selected k neighbors, apply aggregation strategy for rating prediction. So what will be the prediction here? We simply you take the average 1 plus 3 4, 4 plus 4 8, 8 plus 5 13, 13 divided by 4. So it will be 3 point something, right? So that will be the rating for that particular point. Instead of giving important user for each user, who is the closest user, I will give more important. So in that case, what we can do it? So maybe we can use the formula, the adjusted weighted, or maybe the weighted sum or adjusted weighted sum. Okay. So let's say weighted sum. Weighted sum is something called similarity value and the rating. Okay. You multiply it. So let's say 5 users. So here, let's say user U1 is very closest. So you find the similarity value and then 1, then similarity value into 3 and so on. Okay. So another important is you see the while giving rating, some guy always give Amazon, even the Amazon cheating, okay, that guy will give rating 5. Okay. And some guy is very, very strict, okay. He is never satisfied, okay, with any item. So always he gives the 4 rating, not he's 2 or 4, okay, between 2 and 4. Okay. So in that scenario, and then see some faculty members they are very strict of giving rating. He never gets the above 30, above 70. And all other cases the numbers start from 70 to 90. Okay. So these two are different. But how do you know that this guy is brilliant, this guy is very good for giving rating, and this guy is strict? So this best way is to understand, you find the mean. Okay. So let's say mean of the grade is like 85. Okay. So that means that faculty is not very, he is very lenient, he is very good, okay, giving marks. But all other cases, average is 55. Okay. So that means he is very strict user. So therefore, what do we do it? So whatever the rating is he or she is giving, so you subtract from the mean. Okay. So that will give you the actually the whether so he is biased of giving rating or not. So therefore, in the last equation you can see there is a subtraction of the user average. Okay. So this is all about, and then finally at the end of the day you find the rating here, and then what rating you get it, that is here is that is simplest. Okay, and then if you multiply with the similarity value, you will get some rating, and if the rating value is above threshold, let's say 4 and so on, 4 is good rating. So that may be the good item. So let us what is called is like recommend. Okay. So and then for I5 we'll do the same thing. Here also we'll see that that value is 4.2 and this value is 4.1. So obviously the higher will be recommended because I have a choice, or I have been told that you can recommend only one item. Okay. So in that case we provide any one of the two. Okay. So yes. Hmm? User 6. User 6 is the new user and he has purchased 1, 2, 3, 4, 5 years. And he did not give any rating. Now ideally this type of user is called the cold start user. Okay. But actually if you see you purchased mean you must have liked this item. That information will be there in the database of Amazon. From there, if you don't give the explicit information, but they have the implicit information, from there they will figure out. But it maybe the case is I am the new user and I did not purchase also. You are saying they purchased, that is wrong, but I did not purchase it, right? So in that case it is really difficult. So when you start watching the YouTube, okay, still you get the recommendation. So how they give the recommendation? So let's say I started watching the movie, okay. So immediately if I develop a recommender system, so I will give the Titanic movie. So can you avoid? You cannot avoid, right? So that means popular item, they will give the popular item. What are the popular item? Without knowing about you. Now you start watching the movie and then they will start collecting the information about you and then it will give the recommendation later page. Okay. So that is another direction of recommender system, how to provide the recommendation for the cold start user. Okay. So because that system does not have this history. It is not only that. Say suppose new movie came. Obviously no one watch that new movie. Right. So if no one is watching, that this table will be blank, remain blank. So how to populate it? Only content information, they will find these movies with some other content information and they will first figure out with some fake rating by the users and then maybe it will start populating. Okay. Yeah. So now we will be talking about, this is done. So target now is the item based collaborative filtering, but task remains same, whether it is user based or item based. What is our task? Task is to provide, you need to provide the recommendation to user U4. Okay? User U4, yes. So we'll do the same thing. Whether the item I4 or item 5. We'll start predicting the rating here and we'll start predicting the rating with I5. So now here, earlier what we did, we computed the similarity along the row wise. U4 with U2, U4 with U3 and so on. Now, how do you compute the similarity? We will compute column wise. So, this is the target item and these are the already consumed item. I will compute the similarity between this item with this item, this item with this item, this item with this item. And let's say there will be, I am a guy who has rated many items, then I need to select the few items which are basically similar to the item to be purchased. Okay, and then accordingly we will predict here. So identify the item rated by the active user, that is very easy here. Find the k nearest item to the target item, so that is the k, and apply the aggregation function. So adjusted weighted aggregation function is same thing, the item which is closest similar, so that will get the more rating and so on, so more weightage. So then we will have the similar formula here. Okay. So this is something called item-based collaborative filtering. Now we are talking about many times you find the similarity between user to user, and then I said find the similarity between item to item. How do you find the similarity between user to user? I already told is like Pearson correlation. So that is a formula for Pearson correlation. Okay. So only I will not ask you to how to compute. Okay, that is very easy. But just I will tell you how actually it is computed. So there is little difference. If you directly use the Pearson formula available in the what is called this in Python library, that will give you different results. So why it will give different results? So maybe here Pearson correlation between U4 and U5. Okay. So what is the U4 history? U4 is 44500 because not rated means 0. 0 means actually not rated. 0 is not the value that he has given rating 0. But in a matrix, in a computer, you have to have some values. So therefore we write 0. So 44500 and U5 24052. So now you compute the Pearson correlation, you give this to vector to the Python library, it will give some results, but that result is wrong in the context of recommender system. Why? Because 0 will be considered in this Python library is a value, but here 0 is not available value. Okay. So therefore, what we have to do it? So between U4 and U5, what you have to do it? So you have to see the wherever both user rated. Both user rated here. So here this user has rated, but this user we don't know the rating. So here is same thing, here is same thing. So then wherever the both user rated, we can take only those values, but the rest of the values we need to ignore. Okay? So if you use the Pearson correlation. So Pearson correlation was introduced in 1900 and so on. Okay? So that time maybe it was introduced for different purpose. Okay? So, but nowadays other similarity measures came into the domain. So that they use in different way. But I am saying the traditional similarity measure, they will simply ignore this rating and this rating. So now the formula, if you go, so here is, first they are saying is that IUV. So IUV is the item where rated both the user. And then whenever you compute the average, that you take all the average here. So here average will be 4 plus 5 divided by 3. So here also 2 plus 4 plus 5 plus 2 divided by 4. But whenever you compute the Pearson correlation, you have to take only the rating, only the items rating, rated both the user is something called co-rated item. Okay. So rest I think you can easily compute. So co-rated item will be only 2. So therefore you can see the 2 rating is there. Okay. Okay. And for computing the I4, I3, so this is I4 and this is I3. So you have to see the both rating. Wherever both rating U3 and then U1. Then only because we don't know this value here you have to predict, here also you don't know the value. So that is something called adjusted cosine similarity. Okay. So I won't take much time. Okay, I think within 10-15 minutes I will finish. If you are interested, I can continue, but I don't want to that you should lose and still listen. Okay, so that I don't want. So having said this one, so there are some other algorithm here. Is very easy to say this algorithm that is was introduced in 2005. But apart from that, I will tell one interesting thing that I will come back here if it is required. But I will tell this one. Okay, so I hope that many of you are working in AI and others. Okay, so and my observation might be wrong. By what we see is the confusion matrix. I think she had the question on the confusion matrix. So what for confusion matrix? Confusion matrix to evaluate machine learning method. It's not machine learning method. I said like in COVID also we say it's like 100%. So there is also a false positive. So let's say they take the data and something snapped from our nose and it is detected as a, say that guy is positive, COVID positive, and then later on it is tested is COVID negative. Okay. So that is what it is called. That is something called false positive. Okay. So therefore, we should have a very clear idea of that confusion matrix. Okay. So if you have the clear idea, is very good. Just I will restate here. Okay. So what is that here? Okay. Now you need to understand. That is I am here. So and you should never be you will never forget. Okay. So see, this is a two-class problem. Whether you go for the outlier detection, in outlier detection is whether it is outlier or not, you have to say whether it is supervised or unsupervised. And in two-class problem, either it is a positive class, negative class, whether it is 1 or 0. Okay. So now is like there are two possibilities. What is the two possibilities? What we do in the test set. So computer will never see the results. Okay. So computer will tell the result. Okay. And then you have to match that results with the already results available. So that is we do. Let's say, or how do you say? Let's say I have a classification problem. I say is this instant is actually the cat. Okay. So there is a possibility that I might be wrong or I might be right. Okay. So but I am saying it is cat. Okay. It is cat and non-cat, let's say. I am saying is a cat. That means I am predicted as a cat. I am predicted it as a cat. Right. So therefore there is two possibilities. One is the what I predict. So this is something called predicted. So predicted could be positive class and negative class. Let's say predicted as positive class and it is negative class. And what is actual? So this is actual is positive and then negative. Okay. So now what is the possibilities? So I am predicting as a positive class. That means either item will be here or here. Because this is all row wise, all it will be the predicted class and this is will be positive class and this will be the negative class. Okay. So now whatever I predict, so now I will check with the data set. If it is right, myself predicted and it happens to be the same thing. That means I am also predicting positive class and actually positive class. This is only the intersection point. So therefore what I will do it, I will add 1 because 1 instance is adding. Okay. And because both are positive, we say is this instance is called the true positive. Now just few minutes before, I am saying cat, but it happens it is not a cat. But I am means computer or algorithm. Algorithm already said it is positive class. That means cat. Okay. But I cannot keep it here because it is not actually. Then I have to keep it here. So I predicted as a positive class, but it happens to be false. So therefore I will say is a false positive. Okay. So now come to here. So I am predicting as a negative class. That means system is saying it is not cat. Okay. So there is possibilities here. It could be not cat or it could be cat also. Okay. But actually I am saying it is not cat but actually cat. That means actually cat means here. Actual is here. So therefore it will come here. But that is also false. Okay. So I am predicting as a false negative. So that will come here. This will be the false negative. And here is, yeah, I am right. I am predicting as a not cat and actually also not cat. So that is true negative. Any confusion here? Okay. So no, if it is no confusion, so then let's say we change it here. Okay. So now this is predicted class. And this is actual. That means row wise will be actual, column wise will be predicted. So then how do I change it here? So here is like all are positive. That is algorithm is saying all are positive. Okay, so this will be positive class, and but this one is a positive, but actually it is negative class. So since I predicted, so it will be predicted positive class, but it is false. So this will be false positive, and this will be false negative. And based on this value, we compute the precision and recall another thing, right? So precision is all about the how much precise my prediction is. Okay. So therefore precision will be, so this is true positive divided by true positive plus false positive, and then recall will be this side. Okay. So yeah, same name. I remember precision recall. It has same name, sensitivity and specificity. Accuracy is all about true positive plus true negative divided by all combination is something called accuracy. Okay. So actually in COVID and other thing we say the specificity or sensitivity. Okay. So now what I do it here. So recommender system is also an algorithm, so you have to evaluate it. Okay. So how do you evaluate? So we can evaluate in terms of the accuracy in the same way. Okay. But think of how do you evaluate. One thing, before 2009, people used to use one different way. And after 2009, people used why 2000 is so important. Okay. I'll show you few slide maybe. So how do you compute the effectiveness or accuracy, or how do you validate the recommender system? So because initial recommender system was something like that, you predict the value, okay, and how much close that value is from actual value. Let's say I predicted 4.2, actual is 4. Then you compute the mean absolute error or squared error. So that is one way. Okay, so before that you have to divide the data into training and testing. So let me ask you, how do you divide the data into training and testing in case of recommender system? Huh? Let's say you have the data set on the left side. Okay? So now you tell me which portion will go to the training set and which portion will go to the test set. So you know that like 80% and 20%. So let's say in terms of the user, just you tell me. It could be wrong, it could be right also. Huh? So there are 5, right? So you are saying if 4 user will go to the training and 1 will be there in the testing. So everyone agree? No. You have something else to tell?
Other users can be also used as a training set, training data. You can take data from other programs like U1 and U2. They have different types of
No, I want to listen more. No, you are going in the right way. So do you have any idea? So you want to divide the data, just you did here.
We can take the whole data set and see the nearest neighbors, and we can...
No, before doing any process, we have to divide the data into testing and training.
clusters and take uniformly from that clusters we can take 70% such that from all the clusters we have 70 to 30 ratio. So such that no cluster is entirely goes to the testing side. Right, so from all clusters we get the training data as well.
Cluster of users. Okay, anything more? I think you are saying something.
Multiple users, everyone had the different item in their respective boxes. So we have to train the data from multiple users. We cannot go to only one.
Yeah. See, dividing data into training and testing in recommender system is little different from the you apply for the classification problem. Why so? So recommender system is always something the system knows about you and then it provides the recommendation. In case of the classification, the object is brand new. System will not have any information about that object. Okay. So it is not that if you divide the data into 4 users on the top and then this user is actually totally the new user, like 6 user. So because no history, nothing, system knows about that particular user you find. That is not about the recommender systems. So recommender system is all about, it knows little about the users and then it provides, top of that it provides the recommendation. Okay. So actually if you see, yeah, this will be also required, but I will come later. So probably you are saying is correct thing. Instead of dividing the data row-wise, you divide the data typically, I not exactly correct, but you can divide the data column-wise. How? But not exactly the right thing. What we say is, for user U1, he has rated 3 items. So what you do it? You keep 2 items in the training set and you keep off 1 item from the training set, you keep in the test set. For user U4, there are 3 items. Again, some item you keep, majority you keep in the training set and some you keep in the test set. Okay. So basically, if you see the data set of what is called is recommender system, one is called the movie recommender system. So what is the entry in the movie recommender system? You will have the user ID, item ID, and then rating. Let's say user ID U1, okay, and then item ID 10 and rating is 4. User U1, items let's say 20, rating is 3. User U1, item is 100 and rating is 4. And then you start user U2, rating is let's say 11 and rating is 5 and so on. What do you do it per user? Per user you keep 80% in the training set and 20% will go to the test set. Then for each user, some portion will be in the training set and some portion will be in the test set. And the for user which has very less rating, don't keep anything in the test set, everything you keep in the training set. For that user we don't need to test it. For each user no need to test. Okay, at least for 90% users, recommendation is good or not, if you test it, that is sufficient. Okay, so first thing is clear that how do you divide the data into training and test. Yeah, so first you divide the data training and test. What you are saying, that may be the method you are using. But before anything doing for any classification applying, we divide the data into training and testing. Okay, so that is the way we should do. Okay. So now what do you do it here? So system will provide the recommendation and we know the actual. Okay. Then we compare it. Okay. So in the same way we will have the confusion matrix. Okay. So this is a false positive. So when we will get the false positive here? In recommender system, when we will get the false positive? Same concept you use. So if you can tell rightly, then I will say that you understood earlier. When you will say that false positive, yeah, second column it will be the false positive. But which scenario I will say? I predicted as some value, you tell.
You predicted positive, but actually it is negative.
I predicted as a positive and then actually it's negative. So how do you decide which one is positive and which one is negative?
If what I predicted is actually in the
So all rating is above 1 to 5. So then you have to fix a threshold.
when I
Fix a threshold. It above some threshold. Let's say 3.5 is a threshold. And I predicted as a value is, let's say, 4.1. So that could be true positive, that could be false positive. So when it will be false positive? If the value in the test data set is less than 3.5, so then it will be false positive. Here is nothing to do with true negative. We have nothing to do with true negative here in case of recommender system. So only we deal with three values: true positive, false positive and false negative. So we have nothing to do with this part. Let's say this is actual and this is predicted. Okay, so let's see. So that movie, the system recommended these two figures, you can easily identify, and actually this is the case. So therefore, what will be this value? It will be false positive or false. Actually, this is also the relevant, and this is also the relevant here as predicted. This is actual and this is predicted. So then, where it will go? False negative. Where it will go? Which item will go to the false negative? Rightmost. So this is predicted as a positive, but you don't see here, right? So therefore, this will go to the false positive. Let's see. Yeah, this is the false positive. Okay. So now for this item, this will be false negative because system did not predict it. System did not predict it, so this will be false negative. But actually it was positive. But system failed to predict it, so it will be false positive. Okay? And then this will be true positive. Okay? Let's say this one. Okay? So recommender system predicted 3. Okay? Now what happened? So this is matching with this one. I am seeing the only picture. Okay? So this one also relevant. This one also relevant. So these two will be. This will come under false positive or negative. False negative. This will two will come false negative, and then these two will come under. But thing is that is 3. Okay, so this figure is, this is 3. So another scenario. Let's say recommender system predicted this movie. Okay, that means it is predicted as a positive class, but in a system we don't know the rating. Then what do you do? So you answer to a question to a teacher. Teacher does not know the answer. So then can the teacher say that you are wrong? No way. System is saying is this is a positive class. Yes, my answer is correct. But system does not know whether your answer is correct or wrong. So therefore, this type of rating we should avoid. So therefore, we will only provide the recommendation only those items which are known to the system. Known means are known into the test data set. Then only we can say no, otherwise we cannot conclude whether it is correct or wrong. So that is the typical scenario is shown here. Okay? This is another way that I already said. So let's say so this is the training data set here. This is the data set here. So develop a recommender system based on the popularity of item, evaluate the recommender system. This is the entire data set. So now you develop a recommender system that is based on the popularity. So what is the first task for recommender system? You have to divide the data into training and testing. So dividing the data into training and testing, as I said, for each user you remove some items rating. But you keep it in the test set. So therefore what we can do it from each user, we can remove, let's say we remove some of the rating test set. Okay. Red one is actually the rating I remove. So for item U1, I2 is removed. Okay. So you have the training set here. So you have the training set here, right? So now what you do it, you compute the popularity for each item. How do you compute popularity? You just take the addition of the all ratings and then divide it by number of ratings. So then I1 has the popularity 3, I2 2.75, I3 3.67 and so on. So you get the popularity. So now you predict the rating for U1. So what will be the rating for I2? Because you are taking the popularity. So 2.75 and so on. So that is predicted by the system. And what was the actual? So that is 4. So 4 minus 2.7. This is very simplest. Okay. No wire is used, only the try example. So 4 minus 2.7 will be the root mean square error or whatever you say. Okay. So this is one example. Okay. Now there is something called precision at K. So very often what we do, even though you search, okay, so it gives the list and hardly we will see 1, 2, 3, 4. Beyond that search we don't see. Similarly in recommended list also, if they give the list of 50 items, do you see the 50 items someone will look into? So it will see only the top few items. So therefore instead of providing rating and so on, so people started looking into the, keep the rank list of the item. Okay, you give the top 5 items. Okay, so that is, we evaluate the recommender system based on how good the rank list it provides. Okay, so that is something to compute the, so let's say one recommender system is providing rank 1, 2, 3, 4, 5, some items, and other recommender system is also providing other rank. So how do you compare which one is best? So then there should be system to compare rank to rank, right? So to compute this one, there is something called NDC, normalized discounted cumulative gain. That to compare the rank. Now it is actually all recommender system, they compute something called normalized discounted cumulative gain. Not like say 2009 and before people used to compute the MAE or root mean square error. No longer now they report the root mean. People report the precision recall, F1 measures, precision at K, and then NDCG. And why is 2009 I am repeatedly saying? Okay, so to that I will come back here. But let's say what is this? What is the beauty in 2009-10? Let's say I will start with these slides. I think again I have here. This way. So there is actually something called Netflix prize competition in 2009. You may not heard it. Let's say here. In 2006, the online DVD rental company Netflix announced the Netflix prize contest. Okay, with 1 million reward to the first team who can improve its recommender system's root mean square error performance by 10% or more. So as you see 2006 and onward, people used to use the recommender system accuracy in terms of the root mean square error or AME. So they declared that if anyone, they provide the data set, okay, they test data set also, but results was held with them. Okay, so you develop the recommender system, and if their recommender system accuracy can be reduced from the present 10 by 10%, they will get the 1 million prize. And because of the prize, as you know, wherever money, so people will move also with good purpose here. Okay. So therefore, after 2009, actually people came to know there is something domain is called the recommender system, and invested so much. Okay. And due to that, the guy who got this team who got the prize here, $1 million prize. So that is actually that corresponding model is something called matrix factorization. So matrix factorization has become so popular from 2009 onwards till 2016 onwards. That was the sole what is called is like method for providing recommendation and variant of matrix factorization. But after deep learning, so they implemented matrix factorization in different way with nonlinear dynamics in Netflix. As you know that PCO was very much for quite some time, and then now autoencoder. Similarly, Netflix awarded algorithm that is matrix factorization. So that now is used in nonlinear way. So that is something called the what is called neural collaborative filtering was introduced in 2007. So that is why I am saying before 2009, scenario was different. Very limited people used to do research. Okay, after 2009, now everywhere is recommender system, as you can see. Okay, I think I can stop, but I was somewhere. Here? Yeah. So I was talking about normalized discounted cumulative gain. I will show you one example here. So these are something here. So basically, let's say we will see whether we can learn from the example. Machine learn from example. Okay. Let's see whether we can learn from example. Okay. Directly, I am telling you. So let's say ground truth. Ground truth means actual. So there are items I4, I3, I2 and I1. We list them from the descending order. So I4 will appear if you make a list rank. So I4 will appear first, then I3, then I2 and I1. Okay, that is the ground truth. Now we have a recommender system on the right side. So ranking function, ground truth, and then we have the recommender system on the right side, where the first item I3 they put on the first position, Then item I2 they put on the first, second position, item I4 on the third, and I1 is 0. I1 means I1 is in the fourth position. Okay, so what we have to do? We have to say the right side, that is the algorithm provided ranking is how good it is. Okay, so for in that case, what we have to compute? We have to compute the ideal DCG. What is ideal DCG? Ideal DCG is like we have, whenever we move to the from first list to second list, okay, and second list to third list, our attention actually decreases, right? So therefore, to make this attention decreases, we divide, rating value is divided by the position. So it is on second position log 2, so next third position log 3, next log 4, and so on. And this was the ideal case. First was 2, next 2 by 1, so we get this value 4.309. Okay? And this is actually the reference state that is provided by the recommender system. Okay, so therefore first is 2 and the second is value is 1, 1 by log 2 plus 2 by log 3 and so on, so we get this value, and then we divide this value by this value, so we get the normalized discounted. Okay, so I think this part you will understand after seeing your place and can, so but you can go through this part, otherwise it's like you just see is like how do you compare two ranking? We have a rank of list, item 1, item 2, item 4, and then some other guy, other recommender system also provided the rating, ranking, some other than 3, 4 ranking we have, that which one is best. So to compare, we have something called the NDCG. Okay, so you go through this part and then we can. So with that, I think I can stop here. If you have any question, you can ask. Okay, otherwise it's fine. Any question? Topic.